great place to start is, what is data science? I did a quick search, image search, and found this word bubble. Comes a lot of different terms here. Big data, petabytes, all sorts of stuff. But what is data science? What do you think data science is? Does anyone have a?
Trying to get meaning out of data, arbitrary data.
Okay, I think that's a good enough definition. Wikipedia has a pretty close to that. It's they define it as data science is a data-driven science, and it's deploying the scientific method and processes to pull meaning from your data, whether it be in a structured, a SQL database or some other form of structured information or unstructured. So it's all about getting insights from your data, and since we're dealing with so much in this era of big data, so buzzword, using lots of different methodologies that are similar to data mining. Another way to think about is, what is a data scientist? I think it's a very broad term. So some things that I find common around different fields and disciplines of data scientists we can talk about, but there's data scientists in finance and hard sciences like physics and astronomy and astrophysics, also in retail and all sorts of different disciplines, but there are some commonalities. First one is an expert level domain knowledge. So if you're in finance, and you're a data scientist, you probably know a heck of a lot about finance and your specific role in banking or whatever part of the financial sector you're in. If you're in chemistry or biology, you probably are very knowledgeable about your specific domain that you're in those fields. Some mathematics that come with that are, whatever is in that domain. The mathematics of someone in finance is going to be very different than someone in working at, CERN doing data science there. Lots of statistics, lots of linear algebra and calculus. A lot of that comes in play in some of the deep learning and other algorithms. But statistics is probably the most used field of mathematics, at least that I've encountered in data science. There's some computer science things that are pretty common. Data structures seem pretty obvious, but a lot of times it's good to know at least a little bit about networks and distributed computing. Multiple programming languages sometimes, Python being one of them, but you might also find data scientists that use C++ or Java, or you have SQL and other languages thrown in there, algorithms, and of course any domain-specific technologies. So Python comes in, I think, here with Anaconda as the main distribution. Python, the core language, you can do data science and you can do a lot of things with it, but I think the bulk of what you would find, the libraries, the ecosystem, can be kind of encapsulated with Anaconda's distribution. It's both a company and their version of Python. So let me pull up their site here. They have solutions for just about everything. They work with a lot of different industry partners from IBM and Microsoft and all sorts of different industry companies. Let me see here. Whoops. Crazy. did my presentation go? Oh, there it is. So it ships with, current version ships with Python 3.6. It's compatible across just about every operating system. So Linux, Mac OS, Windows, over 1,000 different data science libraries. And it's also comes with the Conda packaging and environment manager. So if you're familiar with Python and pip, it's very similar, but it handles a lot of dependencies differently than pip. So pip handles your Python dependencies. Conda also looks at different languages like Node and other different languages to make sure packages will be compatible with your environment. So it handles that, and it has some similar features to virtual env, so you can set up a different environment right at the command line.
Can I ask a question? So is there a table that maybe compares what is in the current 501 version that you get with 3.6 versus if you're using 2.7.2 Python?
Sure. Yeah. So the Anaconda website actually has great documentation for all their different distributions. So they do have a Python 3.6. They even have a 2.7 distribution. They have different versions for your x86 versus 64-bit architectures. So they actually do have a chart of what's shipped in the package and what is available in the Conda environment to be able to pull into Python.
Well, as you know, if we're new to it, is it necessary to jump right into 3.6.3, or is that just sort of refinement of the features? Is there any big bang for your buck we're going to get, in other words, from being the latest rather than the earlier version?
I would say there's a lot of advantages to being with the latest version of Python. 3.6 has some pretty nice improvements under the hood with performance. So that alone is worth getting the newest versions. There's also some updates to different dependencies and libraries that come with Anaconda. Some of them we'll go over. So you'll have the latest updates of your machine learning libraries or your visualization libraries. So along with the core Python performance improvements, there's also going to be additional packages and all sorts of things. So if you haven't already started with Anaconda, it's pretty friendly with multiple Python installations too, so you can pull it into an environment that works for you and kind of get up and running. It also ships with the Spider IDE, which it's visually pretty similar to MATLAB. So if you are coming from one of those proprietary languages, you might feel pretty comfortable using that IDE. A lot of the layout and features are very similar. Anaconda also offers a cloud service, so you can actually set up environments in the cloud. You can store your work books in the cloud, and it makes it really easy for sharing. They also have a mini Conda. So if you have a constrained environment, you don't have the resources for the full-blown distribution, they offer a smaller version that has most of the core functionality. The company Anaconda also has been offering enterprise solutions and training and other resources. I think they're beginning to not just offer the Python itself, but services to kind of further data science in Python.
Do you know how big the full-blown version is? Like, if they're offering a mini, it speaks to me that the regular one must be sizable enough to merit that.
It's at least a couple gigs. I don't know the exact size off the top of my head.
Sure.
For Windows, the installer is about 5 gigs. I mean, not 5 gigs, 500 megs. Miniconda, I think, is the last I read was it's under a gig in size, so it's more compact in physical storage as well as reducing some of the other extraneous libraries. It's kind of the best hits of data science. So if you're looking to get started with Python and data science, I don't think, even including other languages, I don't think there's a better solution to data science than Anaconda. It's very robust.
Have you used R? I'm just curious of how R compares to Python for data science. It used to be, R was the language for data science. What about now?
So R is, I have used R. I find that it's very good at what it does. It's very good at statistics and doing, even really good at machine learning. I think the problem is if you want to do other things other than your core analysis or your core data science, and you need to pull in some data with, off the web, and you want to do some web scraping, R is probably not your language. If you want to work with your DevOps team and kind of make sure your modeling can go into production, R may not be the best language for that. You'll have to go through more hoops. So Python kind of offers the ability to be flexible more than R does. So let's go into the different packages. I'm not going to go through every one of them, as if there's over 1,000 different libraries available. I'm highlighting a few of the core ones that you may come across online or find immediate use for. The goal with this is not to be comprehensive with these libraries, because each one of these really could be their own talk, but they kind of give you a feel of what they offer and how they fit in. So the first one I want to talk about is NumPy. NumPy it's the core numerical computation library for Python and data science. Just about every other library that I'm going to introduce tonight is going to rely on NumPy at some point. It is completely tweaked for performance. It's built using CPython, so it's very fast. It relies on an object called the NumPy array, which is an arbitrarily dimensional array that you can it's pretty easy to construct and use. It has a lot of functionality for linear algebra, Fourier transforms, and some random number functions. There's a lot more. I'm going to point you to the great NumPy documentation online if you want to go deep dive into it. It actually has some great tutorials. But kind of moving on to show off kind of some of what it can do. It's really easy to get started using NumPy, so you just import. NP is usually the most common abbreviation, so I'm just going to import it. If you want to set up an array of an arbitrary amount of zeros, which can come up pretty often, you just put np.zeros, pass in the amount of zeros as your argument, and there's your array. And of course there's a ones function, similar, pass in your ones, the amount of ones. Now, to kind of show the random number functions, I'm going to call the random int function. It takes two arguments, the integer it starts with, the integer in the range of the integers essentially. So I'm going to print out 5 random numbers. Pretty easy, pretty quick, and show that it's random. Just run it again. So every time, it's as close to a random number generator as you can computationally get with floating point.
Okay, so I know that random is a standard library module.
Mm-hmm.
Do you know why random is also in NumPy? Is it a speed optimized thing? Or do you have any reason for why that is? No.
I don't have a good reason for it. I would imagine it is performance, since it is also pretty convenient to have within this library that's tuned for numerical computation. Be able to use it with your NumPy arrays. It's probably, I don't have their specific reasoning, but I would imagine it's performance related.
It could be they've got their own algorithm for generating random numbers that's better than the standard random number generator.
Or maybe it interfaces with their arrays or something like that. In a way that
Yeah.
the random logic
You can
is-
create arrays directly, so if you wanted 10,000 of them instead of making a list and then converting it to an array, you can do it directly.
Cool.
Yeah, so I'm going to, actually speaking of constructing arrays, I'm going to construct an array with lists here. This is going to be a two-dimensional array. So you have passed in two lists. Notice the double brackets there for the showing the dimensionality of this array. So we have our first row in the matrix and our second row as I pass it in there. So it just takes in as arguments. You can also pass in other functions like random numbers from the random library. I'm going to go through and show some of the matrix multiplication that I can do. So I'm going to assign to these variables some arrays here, and then I'm going to do, matrix X and times matrix Y forms matrix multiplication as you would expect. They've also implemented for dot multiplication. You have the np dot, or you can use this new shorthand that they recently introduced using the @ symbol. So it produces the same results, your dot multiplication. So if you want to construct an array, there's a quick way you can do it with arange. So this function, you pass in where the number you want to start with and where you want to end, and of course is a zero indexing language, so this will go from 10 to 50. So pretty easy. You need an identity matrix. You can pass in the size.
Do you know, just off the top of your head, are those floating point or decimal when it's created? Or does
I don't know
NumPy
off-
handle its own number type?
I don't think it's handling its own number types. I don't remember if it's decimal or floating point. I'm sure the documentation
No,
will
I know.
go in.
Just since it's throwing a period after all.
Yeah, I felt the same thing. I'm like, what is that? A float? Is it a double or?
Yeah, 'cause
Yeah.
if they're already starting with arbitrary precision, like that's sort of interesting approach, but performance side savings.
I took a NumPy course and I didn't see it using floating point, it was just using decimals, but maybe there might be something to do that, I don't think.
So I don't have the answer on the number type, but I'm sure yeah. So
There may be a different kind of array, like, right, is there extensions to the array, like, inherited arrays?
There's all sorts of different, you can find all sorts of different kinds of arrays. So I'm not sure I have the right answer for that, but as for kind of showing off more of the entry-level functionalities for NumPy, the last one I want to show off is just transposing a matrix. So we have arbitrary matrix here, and I'm going to just transpose it, and SymPy shows up. It'll transpose a matrix as you would expect. So it's a pretty powerful library, a lot to dive into. I don't have all the specific technical answers for the library since it is very, there's a lot to it, but the documentation is very helpful. The next library I'm going to go over is SymPy.
Quick question about that.
Sure.
So I've seen there's a matrix type along with the array that was supposed to handle matrix multiplication more natively, but that I've never seen the end symbol before, but that's pretty elegant. Is matrix obsolete because of that? Do you ever use the matrix class?
I really don't use matrix at all, but that's partially because of the domain. I don't really need to do that much matrix multiplication. So honestly, I don't have an answer for you. I'm sure there's some performance considerations that went into that for more specific multiplication. So
If we were to get matrix multiplied into this standard language, right? Is that what happened?
That would be news to me, but that would be awesome. But I don't know.
Proposal was out there. I don't know if they ever actually did it.
I thought they did.
I think in 3.6 they might have. I think it was the infix app that they used.
Yeah.
But
That sounds
I read the
familiar.
PEP and can I come up with it? No.
So cool stuff is out there. Science, data science is influencing Python language, which is cool.
Yep. So the next library is SymPy. This is a symbolic mathematics library for Python. For those not familiar with symbolic math, you probably are, but just didn't know it. It's oftentimes, if you're taking algebra or you're taking calculus in school, you're probably going to be using symbolic math, and rather than, if you're taking a square root of a number that doesn't simplify down to a nice number, a lot of times you'll, for example, reduce it down to something like, say, the square root of 8. The actual number is 2.8, blah, so on. But with SymPy, you can have it expressed as 2 times the square root of 2. So it can help with, if you're in a domain where that's necessary, you need to express your computations in this way. It's very useful. The way it handles that, you can pass in different different strings as arguments to the symbols function, and that maps those to symbols that you'll use in your math. So here is going to print out the function here, which is the differential sine of x times with x, and it's going to be expressed in terms of x. So the answer below, you have everything in terms of x, but you can easily change that to a different symbol if your domain require, if you're specifically working with, you really need a tau, you can map that.
So this is for differential equations then? This is the main,
It's not just for, I wouldn't say only for differentials. The library itself, they actually claim that it's used a lot in statistical modeling, but quantum computing. So if you find that you really need to express your mathematics in this way, you really can't, and decimals this won't do. I'm not sure it's specifically for differentiation, but it's just a good example for this.
do you know that, if it's used for quantum computing, then does that mean you can work in a task-oriented way or a multi-object way, and you can spin off an equation computation in multiple sort of object tasks?
I don't have the answer to that. I don't really use SymPy personally, mostly because I'm not working in a domain where that's helpful. So the documentation online is going to probably give you all your answers there. So they actually go and they have lots of different examples of projects that currently use them and examples. So you can go to specific Python libraries. They'll have all sorts of different explanation of how they're using it and why, so that it's not just a how-to, but also who's using it. So it's a pretty great resource.
Just to get rid of this, the function call. I want to see the latex version. Can you print that out? I want to see it look like math.
So, speaking of that, I'm going to not only change the,
That's nice.
yeah.
What keystroke did you hit?
So in the init printing function there, your environment needs to have all the dependencies to handle latex, but it does support that. So not only did I change the symbol, I enabled latex on here. So it's just use Unicode equals true, and there you go. There are going to be some dependencies you'll likely have to set up for your environment, but it's pretty easy to use Conda install for that.
Is that because you're using Spider? Is that, and you've got a latex plugin or what?
I am not using Spider. I'm actually using a different IDE, which I'm actually going to cover. It's called Jupyter Notebooks. It also comes with Anaconda, which it's right now my favorite IDE for, at least for data science. Do another example.
Are you going to kind of cover how to set up either Jupyter then, or
Just set up
how to set up Jupyter, or you stand up Jupyter and it comes with this capability? Or what?
Jupyter is built off of IPython. I believe it's a. I'm trying to think of the best way to describe it. I've only really used it through Anaconda, so I've never had to install it with a different version of Python. So I'm not sure I'd be able to walk you through that, but it's it's pretty easy to use when it is installed. So I don't have Matt. Have you ever?
I've never installed it directly, so.
You have?
I used IPython. So IPython was different, like interactive Python, you can test each line. But then Jupyter made a notebook kind of environment. So that's called Jupyter Notebook, separate. It was Jupyter Notebook where you can save your own work with output and all. And you can run each cell like this. So that was separate from IPython, but now it's combined. It's called, and that is all inbuilt with Anaconda. So if you install Anaconda, it's there already, and you just need to write Jupyter Notebook. It opens
Yep.
this one in any of the browsers.
Does it run like a server? I can't
Yeah,
recall.
it's essentially.
Backend server that
It's a
runs and then you
local
launch the
host.
web browser.
Yeah, so I can pull that up. So I can't really read my command prompt there, but yeah, it is running a local instance here. So
it's like you're on port
80.
88
Yep.
up there. Okay.
Yep.
What about how to use PyCharm? Is there any, that's about the only thing that I want to use for programming Python, because I want all the advanced IDE, auto completion and everything like that. Is there any sort of, does Anaconda have some plugins, or, I mean, you can just write pure Python.
Yeah, I use PyCharm. I use mainly PyCharm for that, and in that you can open this notebook also. If you have a notebook saved separately as IPYNB is the extension, you can open that in PyCharm.
So any questions on SymPy?
Why didn't I have it in my calculus class in 2002?
Yeah, it's.
Is that relatively new?
It's been a part of Anaconda since I've been using Python, so I'm not really sure when it was introduced, and I don't really know much about the history of when it was, when it kind of entered the PyData ecosystem.
Because I always thought you had to use MATLAB for that kind of work. MATLAB has that scripting environment, and so I never knew you could really just do the equation right in Python, essentially.
Yep.
But the symbolic computation, that's pretty much what Naval Mathematica do. Is this a serious competitor for either of them?
I think not just the SymPy, but being a part of the ecosystem, there's other things that Anaconda and Python combining SymPy in there, I think makes it a pretty serious competitor.
Because they're expensive software.
Yep.
Yeah.
Yeah, so I think one of the big takeaways for me is one of the reasons I like Python, but kind of champion it is not just comparable, but sometimes it is can be superior to some of the proprietary competitors. Offering open source versions of symbolic mathematics, and also the next library I'm going to talk about is SciPy. This is probably the core scientific computing library. Of course, there are other things it does, but it's really has some great engineering and scientific libraries. Integration, optimization, Fourier transform, signal processing. It even has libraries for importing MATLAB files, which is kind of nice. So anything that you were modeling in MATLAB can just
migrate right over.
Yep. So it's got some. It is for some serious science in Python.
I think this has been around separate from Anaconda, right?
Yes.
Both heard of this.
Yes. So SciPy itself is an org, and there's the SciPy library. So the SciPy org has, NumPy is a part of that. I think Pandas, a few other libraries, kind of in that ecosystem, and then it's the kind of the arm of hard science for Python. I don't remember exactly when they came around, but they have been around for long before Anaconda. So, I'm going to just show off a few different libraries, but there are so many different functions. Definitely take the time to explore what your specific domain uses, or just you have an interest, you want to pull in different file types into Python, see what you can do. I'm going to show off in the spatial library the Delaunay triangulation. I'm not going to go into what that is, just kind of show you how easy it is to use. So I'm just going to import from SciPy the spatial library and Delaunay class, I believe it is. Also going to import NumPy because it has an argument. I'm going to pass in NumPy array, store that as points, which will then be passed to the Delaunay class. So print that out here. So it's class of the triangulation points are in the Delaunay class there. It's not super helpful just seeing that, so I'm going to go ahead and plot it using matplotlib, which we'll cover in a little bit. But those 4 arbitrary points, the library is able to triangulate them with through the I guess I don't know what the right terminology is for the triangulation, but pretty easy to do. It's pretty fast. There's all sorts of other spatial libraries.
Actually, I got a general question on the performance. So, have they got this heavily optimized with C code or something? Because in general, Python is like, I keep wondering why so many data scientists use Python, because speed-wise, it can't compete anywhere near like C++ or something. Do they just have it heavily optimized and then back in with C code, or what?
That's part of the reason why NumPy shows up a lot, but yet there's a lot of C optimization under the hood for a lot of these libraries, especially SciPy. So it's not your average Python for a lot of these libraries. So just to show some, this class has a lot of different different properties you can call, your min bounds, and I'm going to call points just to. It's pretty easy to call the property, and there you go. The next function I'm going to show off is in the optimize library, specifically minimizing the Rosenbrock function. If you're not familiar, I wasn't before reading about this. It's a non-convex function that's used a lot as a benchmark for optimization algorithms. So this is for those that are into the math. There's the specific function that's going to be minimized. Got the code here. I'm going to import NumPy again. Import optimize in the minimize library. And something I'm going to do differently here is I'm going to define the Rosen function as a Python function. And it all, you can see it all in Python will relate to that. My initial X point is this NumPy array. I'm going to pass into the function this Python function here, the initial x0, the specific method that's being used. I'm going to show you there's lots of different ones built in. It has a fabulous doc string, which is one of the best things about these libraries. They're well documented. So you can see all the different kinds of methods that are available to you. I'm just going to use this one for really no particular reason other than to show that it's an option. You have another option here to this display here will show this here, so you can see what the current function value is, the amount of iterations and evaluations that it took, and the final result.
Are you able to explain further how to use it as a benchmark? In other words, are you using it within itself, or are you adding? Is it to add other methods to it to use it as a benchmark against your methods? How do you use this?
That function or the library itself?
Well, yes. So just in general, the function is saying it can be used as a benchmark, right? So if you have your own method that's implemented an optimization algorithm, is that what's meant to be a benchmark against?
It's more against the minimize library itself. So the amount, so you can measure by time performance or how many iterations, if it comes up with the right answer. Lots of different variables that you want to measure, but that's more or less what that function's for.
So it is it, so if you know you're putting in so many loops or so many numbers and so many, and it's computing the time, right? And then and that you get result. And then if you make your own method and you're doing a same amount of numbers and computational complexity, right? Is that what it's trying to benchmark against? And this is better, or
Yeah, more or less that's more to compare against different optimization algorithms. That's really getting into the computer science side of this. So it's a little bit more into the depths of just optimization in general. But the point of showing this off is how easy it is to use the minimize function, the different options that are available to you, and how you can easily measure what you're doing. So not only the result, but how many iterations, and if you want to pass in time, you can measure that as well. So SciPy has that long list of different libraries. They each have tens of different specializations. So if you're doing science and you really need to you want to use Python, it's got so much in there that's it would be probably 2 or 3 different talks just to cover a surface level amount of it. So strongly encourage you to explore it on your own, see and just play around with it. So any questions about SciPy before I move on?
You said that was scipy.org is a resource site?
Yes, I can pull the site for you. So this is the specific library page, but scipy.org, like I said, it's kind of an umbrella of different libraries. It's scientific computing in Python. So it's there's a lot more to it than just the library, but the library itself is very, very rich. Back here. So the next library I'm going to cover is scikit-learn. So this is the first machine learning library covering. It is built heavily on top of NumPy and SciPy. Has a lot of the kind of the go-to algorithms. Your classification, your regression, different clustering algorithms. So it has those already built in for you. So you don't have to construct from scratch. If you're doing a neural network or something, you don't have to construct everything from scratch. Makes it really easy. The other thing that it comes with that I find very useful is it's very easy to do pre-processing, separate your data out pretty easily into testing groups. So you can also do a lot of cross-validation. There's a whole cross-validation library in scikit-learn. Also, fantastic documentation that goes into every one of the libraries. So one of the best parts about it, other than simplifying machine learning, is it makes it really easy and approachable, because you can kind of find your algorithm of choice, your k-nearest neighbor, and kind of learn what it's able to do, what you're able to kind of tweak with it. Go back. So the first library I'm going to show off is how to use a multi-layer perceptron or a basic neural network with scikit-learn. So just visualization of a single hidden layer neural network. So from scikit-learn neural network, I'm going to import the multi-layer perceptron classifier. So let's go ahead and import it. I'm going to start with my data here, my data points in my labeled data, and passing into the classifier. You have a specific solver. You can tweak the parameters of the alpha, the amount of hidden layers, so all the different various parameterization of these machine learning libraries you can do right here. So we can go ahead and run that and pull up the doc string to show all the different kinds of parameters that you can tweak with. So you can change the activation function. You can change, between logistic, all the different kinds of activation functions you can think of, different solvers. So it'll kind of show you what it ships with, and if you like, since it is open source, you can also play around and do your own. If you have your own activation function, or you can pass that in as well.
Do you know, so one of the hard things I find about data science is I'm not so much of a scientist anymore, and there's a lot of new stuff that has come out with regard to neural networks and such. Does the documentation for these also introduce the concepts around them, or do they expect you to, like, here's the what, the how, the why, you need to go study elsewhere, or is they kind of guide you a little bit? Like, I'm just wondering, like, as someone getting into data science, how do you manage using the tool and learning about the tools at the same time?
Yeah, so the documentation does do a pretty broad overview of what they're for, and how to use them in Python. As far as really learning and rigorously understanding the mathematics behind them, it's going to do a little bit of that. So actually, we can look at the documentation for, oftentimes I find the best way with scikit-learn is to just look up the algorithm in Google. It's a little faster sometimes than going through its website. So the documentation is very, specific about the tool. So it's not going to give you it's not going to give you everything you need to kind of get started. This is not your starting point to learning neural networks or learning about machine learning. It's more of your starting point on how to use this particular application of it. There's a lot of different ways to learn about these algorithms. I would say the online resources through MOOCs and things on YouTube and various other sources are probably better than going to the scikit-learn documentation.
Are there a lot of, is there any YouTube channels about Anaconda?
I believe they have their own channel.
Okay.
I get their videos all the time when they have their own Anaconda conference. I don't remember what it's called.
How are they? Instruction-wise,
I learn a lot of when I watch the Anaconda specific ones. I learn a lot about very specific applications of they're a lot of times showing off the platform, so it's not the best place to learn about say the core data science that's going on, but they do a really good job of highlighting all the different pieces that are going on, at least from their conferences that I've seen.
besides the official YouTube, I found this with Android lots of times when the official videos about some new topic are kind of dry and not very informative, and then you find some guy who basically is doing a webcast of him trying to figure it out, cursing a lot, and that's a lot better. It explains it.
Yeah, a lot of especially around the machine learning algorithms, there are some really good YouTube stars out there in explaining how a lot of this works. There's one guy, I can't remember, I think his name is Stephen Welch. He has a whole series it's called Demystifying Neural Networks. It's pretty good way
What's
of...
his name?
Stephen Welch, his YouTube channel is Welch Labs. He's a machine learning engineer somewhere. I don't remember exactly where, but he does a pretty good job of kind of breaking it down. He uses Python to construct a neural network from scratch. So he's not using scikit-learn, but he does a very small single hidden layer network and just kind of goes through it. There's other resources for the different algorithms too. So
Coursera is pretty good. I did the NumPy Coursera and then walked me through, made you do quizzes, and it was pretty good.
Yeah.
For a NumPy lesson, I forget the title, whether it was I think it was a data science and Python Coursera course is what I think it was.
Yeah, there's a lot of those like Coursera and edX and Udemy, Udacity. Yeah, they all have really, really great resources for learning data science and machine learning. The Coursera has one with a really good machine learning introduction by Andrew Ng from Stanford. It's in MATLAB, unfortunately, but it goes really into the mathematics for all these different algorithms. So if you want to get a really good understanding on how logistic regression actually works, you build it in MATLAB, so you get a good understanding of the math. For Python specific, it seems just about everywhere kind of starts with Python now for a lot of these online courses when it comes to data science. So
Yeah, data science is so huge now. Everybody's offering data science and data science Python class.
Mhm.
Sorry, who was that guy again? The
The Coursera course is called Machine Learning. The instructor is Andrew Ng, so just Ng. Yeah, it's a really great course if you want to get into the mathematical weeds of machine learning. So this classifier object here, I put it to the the x array and the y, the labeled y there. Using the fit method, you can actually also pass that in at this time of initializing the neural network classifier there. So there's other methods like predict. So pass in another array, it'll predict the outcome using this trained network. So one of the things about this particular library is it does train when it's not there aren't any pre-weights unless you specify them. It's going to actually do the full training when at the time of fitting. So if you pass in different training data, it's going to have a different result, like you would expect with a neural network. So it's in the shape of the coefficients there, since it's all the different as it's going through the layers, the coefficients that it trained and learned. Next thing I want to show off is the grid search cross-validation library. So one of the things that makes this library, scikit-learn, great to use for machine learning is you can easily test different parameters for your algorithm, and you can also test different algorithms. It's pretty easy to do that. So I'm going to import the support vector machine and a test data set, like a sample data set that they have built with the library. It's a pretty common library that you see in machine learning, the iris colors and all the different, it's everywhere. So I'm going to store it as iris. It's loading that data set, passing in parameters. So this is the specific parameters I'm going to compare for the support vector machine. So using different kernels, you have use different a linear and an RBF. There's lots of different options that you can pass in, but you can compare. It's going to compare against them. There's also you can pass in as many parameters there are for your algorithm. You can add to this. Add to this library for the cross-validation. So I'm going to store the support vector classifier here. I'm going to then use the grid search cross-validation, pass in the algorithm, pass in the parameters, and then fit it to the iris data. Oops, I just fat fingered that. And show the as it went through the mean for those different parameters. So you can see it went through and tested those different parameters against each other. So use the linear kernel and the C. Can't remember what that's calling for. Pull up the document doc string here. The error term there. So it's testing different error terms. So it allows you to do a wide array of different parameters for your algorithms pretty easily. So it's just a simple dictionary, and it went and tested that same algorithm on that same data set multiple times to give you the optimal result.
So can you explain a little further Iris and what it's doing here? Is this a color library, a data set
Yeah, so
color?
in data science, you'll often find the same data set shows up everywhere. There's, at one time it was hard to come by all these, public or public domain data sources. So the Iris data set it's comparing colors of flower petals.
Oh, it's a flower. Oh, it's flower.
Mm-hmm. And it's just an open source data set that has been around forever, so it's easy to validate your results against historical algorithms and papers. So along with Iris, you'll see like Titanic survivors or Boston housing prices. Like you'll see the same data sets show up over and over and over because they were public domain many years ago, and a lot of the algorithms were built using those data sets. So next library, I'm going to go over, since go through Pandas. So Pandas is a data manipulation and analysis library. It allows you to pull in data sets from different sources, allows you to do some high-level analysis, allows you to do some manipulation, and some visualization is built in as well. So I'm going to import Pandas, abbreviated PD. I'm going to import some other NumPy libraries as well, which will help with constructing the data frames. So Pandas is built on top of a data frame object, I guess is the best way to describe it, but it's a data structure that's, you can visually think of it like Excel or another spreadsheet, or similar to like R data frames. Allows you to manipulate data very easily and visualize it very easily. So I'm going to create this. I'm going to create a data frame using a dictionary. So passing in for the different rows and columns, labeling them using a standard Python dictionary. Pass it into the data frame, function, and it's going to create it, and I'm going to print it out. When you use the print function in this particular environment in Jupyter, you'll see it in that console printout. But I think the best way to view a data frame is in this environment is just to call the data frame. Jupyter Notebooks does a really good job at making it very readable. It'll come in, especially when you have very large data frames, it comes in handy to pass it in that way as opposed to doing the print function. One of the things with this particular frame here, I passed in some just bad data on purpose, kind of show you the nans there. For whatever reason you have missing data or it just isn't working with the any formulas that you're passing through. You can easily drop nans. There's a function to drop nans, just like that. Now, one of the things to keep in mind with Pandas is most of the operations are not going to stick to your data frame until it has a parameter called in place, and unless you explicitly declare in place is true, it will not save your save the changes that you made. So let me show you that here. So I just ran drop nans. It removed those from that row. If I call it, call counts here. live coding. The original nans are returned because I didn't explicitly tell it to stay in place. It allows you to kind of see what would happen to your data frame with that operation without actually having it stick. There's other operations you can do, like you can replace them with values. So I'm going to fill it with some arbitrary string fill value, just so you can easily manipulate your cells and in there. You can also use random. So this is passing in the random function from NumPy. You can use that to generate kind of random data, which is kind of helpful for all sorts of different reasons. But you can pass in your indexes and have it split them as different rows and have your columns, and it allows you to generate data frames on the fly if you need them for various reasons. Another thing that Pandas offers is a very easy way to pull in data. It has a lot of read functions. This one is I'm going to use this read CSV for your flat files, but it also has you can read HTML, you can read Excel. There's a lot of different options. So this is just an arbitrary CSV, just calling a specific file path, and it just reads it into the data frame. So we pull here. Connect to like a database. Yeah. So. So there are the different read libraries. Yeah, you can call different things like SQL or a specific table. Your environment will have to be specified for that. But there's all sorts of things. If you need to pull in JSON or Python pickle or all sorts of different data forms. So it makes it really easy. You can use it for web scraping. You can use it for all sorts of things. So it's really easy. It pulls it in. It will try its best to find the appropriate labels, but you can explicitly declare which labels to give your data if you're pulling it in from doing some web scraping and it's not well structured. Another fun thing to do is visualize with data frames. So it makes it pretty easy to do some basic things like I'm going to do a histogram here for the distribution of this particular column. So it's pretty easy to just do some quick visualizations with Pandas. It has some matplotlib libraries built into it, so you can start doing bars and lines, chart plots, and histograms, all sorts of things already built in. So it's a great place to start your data analysis. Great place to start to manipulate it, get it in the form you need before you pass it along to your machine learning libraries. Or if you're just doing you just need to get your basic, standard deviations, and have some basic statistic libraries too. So, it's a really great library. There's a lot to go into it, a lot to dive into it. So if you're wanting to do data manipulation, find a data source and just pull it in and play around. The documentation will cover all sorts of things like SQL-like joins, so you can join different data frames together in different ways, and you can pass in different different functions to your different columns and do all sorts of manipulation to it, just passing in. So if you want to do log of everything in column A, you can do that. So it's a really powerful tool in the ecosystem. So anyone have any questions before going on to next library?
So you said you use Jupyter, right?
Yes.
Why don't you demonstrate that one to us so that we see you use that one?
Demonstrate which,
The one that you use, the one you're familiar with, you use already.
what the Jupyter?
Yeah,
Right, I'm actually, this whole presentation is actually in Jupyter.
okay.
Yeah, so I'm actually using Jupyter notebooks right now for this whole presentation. So it's a live environment. So I'm able to, not just do the visualizations and the code, but it does images and markdown language as well. So you can use it as a presentation format as well as IDE. So that's actually what we're looking at right now. One of the core visualization libraries is Matplotlib. So data science isn't just about doing the machine learning, it's also pulling insights out of the data. A lot of times it's hard to see what's happening in some of these higher dimensional forms. So being able to visualize it in your data in different ways is very important. Matplotlib is, it's built into a lot of different libraries already, like Pandas. So it's kind of your, first place to look at if you want to do, various different charts. There's a great way to learn Matplotlib as well as kind of see what it does. Is it has a whole gallery of different, you can barely read it, of different kinds of plots, and it will go through and provides the code on how to do it. It's is really robust, so you can do pretty much fully customize your entire plot. So it's built using the plot itself as an object that you can call, and you can manipulate the different aspects of it, size and the way it's displayed, and you can even do three-dimensional plots as well. So it's the best way to learn Matplotlib and learn about it is actually to look at the different examples and see what you want to learn how to do. And you can go this histogram here. It'll show you how it's constructed, and you can just drop it right into your environment, and it should work right out of the box. So actually, a lot of these examples are actually pulled from the documentation just to show you that it does literally just work. So the first one here is comparing two different plots. So it's I'm going to import the Matplotlib here in PyPlot library and call it BLT. A different function I'm going to call that will apply to the data. So go ahead and run this, and you're able to compare two different views of the data set stacked on top of each other. You can also do side by side, all sorts of different things nested in the corner, and it's pretty much the sky's the limit with Matplotlib on how you display your different plots. Another one to show is pie chart here. Different things that you can control, they explode, and which the way it goes through, and you can pull out different the different segments, and you can pull on different distances from the center. So lots of different things that you can do here. So this the hogs section here it's exploded at 0.1, but let's say we want it to come out a little bit further. It's pretty easy to change on the fly, or so we want to have two different. We want to highlight two different segments of the pie chart. So pretty easy to change different parts of the plot. Next visualization library is Seaborn. which is built on top of Matplotlib. This is an example of a plot with Seaborn, so it can get pretty complicated. But one of the things I like about it is it's a little less verbose than Matplotlib. This is going to be a scatter plot matrix. It's going to import Seaborn. Has a style set there, and the data set, the iris data set again, makes an appearance, and it's going to do a pair plot based on the hue. The hue is going to be based on the species, rather. So pretty easy to create this this matrix here, scatter plot matrix, with a lot less code than Matplotlib. So it's a great way of simplifying your analysis, so you don't have to completely worry about creating all the different plot objects and playing around with that. So it's built right on top of Matplotlib. Some other things that it includes, go through and show an example of here with the Titanic data set. Lots of different ways to, it makes it very easy to change the colors and to make the styling a little bit nicer than the out-of-the-box Matplotlib, which is that flat white. You can change that as well, but it's very easy to just, it's a little bit easier with the set argument style as opposed to the way Matplotlib handles that. It also includes violin plots, which is something that is not included with Matplotlib. Those different plots. So your violin plots are to show the distribution by different various facets. Yeah.
Sorry, I was late. But, so you see when you talk about being built on top of each other and so
Mhm.
forth, does it kind of suggest that they all play well together?
Yeah. So
is that true? Like if I got my data set together, I don't have to manipulate my data set to use a different plotting tool or something.
yeah. So that's the best part about not only these libraries but Anaconda in general. All the libraries have kind of been they all play nice together. There are other libraries that you can pull in that do work very well, and there's actually going to be one I'm going to pull in that doesn't ship with Anaconda but is very compatible. Seaborn built with Matplotlib. They're all designed in a way to work right out of the box. There's no extra configuration I did. I really, right before this presentation, I installed a fresh Anaconda installation for this new version, and just started the presentation of the code. So I didn't really tweak anything. There's a few dependencies that I had to install for the environment that were more related to LaTeX than Python, and then some libraries that I'll show after this that aren't included with the initial distribution but are in the Conda environment. So it's all works very well out of the box, and they all work well with each other and play nice. So you don't have to worry about all the different dependencies and libraries working. NumPy doesn't really like scikit-learn. They all kind of work together in chorus.
Does that mean do they overlap a lot, or do they not overlap much in terms of?
Yeah, earlier in the presentation I brought up that NumPy makes an appearance in almost every one of these libraries at some part in the source code. So if you actually go into their repositories, you'll find NumPy all over the place. So for the final visualization libraries I'm going to show are Bokeh and Plotly. Bokeh actually ships with Python, with Anaconda. Plotly does not, but it is part of the ecosystem. So it's a Conda install, and it plays nice with everything that's included here. So Bokeh and HoloViews, which is essentially a wrapper for it. It's an interactive visualization library. Allows you to do more interactive plots as opposed to the static images So with using HoloViews here, using the bokeh extension, I'm going to display some box and whisker plots here. And notice this extra set of tools here. It's a interactive plot that you can manipulate in your environment, and it plays very nice with Jupyter, so you can do all this all within your IDE. So you can zoom in and really see what's going on with your data. It's a little too much there. And a reset, just in case you get lost.
Does it in any way support actually manipulating the data while the plot's live and changing dynamically?
There are some bokeh plots that do offer that. I think, let me actually pull an example up. I don't have a specific one here, but yes. So with bokeh, I can't remember exactly which one, but there are some where you can have, this is not one. You can have different facets that you can call and drop downs and things that you can use to manipulate the data as you go. I don't have a specific example right here, but I know that the website for bokeh has a great example of it. You can manipulate it right, this is on the web running live, so you can not only use it in your environment, you can also easily put it up on a website.
Does it export to a static form well?
I believe I don't know if, so you do have the save there. I don't know how many different file types. I guess it's just PNG. So I don't know if you can do more than one different kind of file type, but yeah, you can just save the image, and it should be just so it's actually, double check here. Zoom in, save, and it should save as a, oh, I bet it's on my side here. That looks like the zoomed in version to me. So it's going to save the view that you're on. Yep, it's pretty handy.
Can you put the interactive version within a web page?
Yeah, so actually this plot here is a great example of that. So this is Texas County's unemployment rate in 2009, and has this great tool here is hover over a specific county. It's going to display the unemployment rate in your Latin long. But yeah, it does work very well right on a website.
Just generate JavaScript or something?
That's a great question. Yeah.
I think it does.
Yeah.
How did you click over to the website?
I just had the link in my presentation here, so I just clicked.
Does it build that link at the bottom of every?
No, it does not. So this particular site has it deployed on there, but it is not directly created. But there is the next library I'm going to show. Plotly does do pretty similar to what you're looking for, where it'll actually go onto the web. It's a API. For this here, this is hosted on Bokeh's website currently. I deployed it locally as well, where the provided source code. Runs locally, and it plays nice online too. So
when you imported it locally, it built that link itself?
no, I literally added it as part of the presentation.
You added it. Okay.
Yeah. So this link down here is just it's just another cell in the presentation I manually added. Yeah. So great library for interactive plots. This last one I'm going to show off for visualization, Plotly, I think it's one of my favorites, mostly because it's really simple. So I'm going to import a Panda data frame here and some parts of Plotly to do it offline. There's another, so Plotly itself is not shipped with Anaconda, but it is part of the Conda environment. So you can do Conda install. It'll handle for your environment. Runs right away. Like I said the other day when I installed this fresh installation, just did Conda install Plotly, ran this code, and it worked. So very, very quick and easy. This other all
Is everything all of these part of the mini Conda?
I don't know if all of these are. I know this definitely isn't. I would be surprised if all of the visualization libraries are part of mini
At
Conda.
least the ones you did, this is the one that's not part of that?
This is definitely not. It's not a part of the normal Anaconda distribution in general. Yeah, I don't know the full list of what is and isn't in Miniconda, but they do have some really great. It's a chart that has a checkbox by does it ship with Anaconda or not. So I'm just going to create all this other library cufflinks. It binds Plotly to the Pandas data frame. So creating just a data frame full of random data here. And that's just a 5x4 column there. And another one just for different categories to make it easier for labeling. The first one here is a bar plot. So I'm calling my data frame. I'm going to pass iPlot and pass the argument bar and assign the labels for X and Y. And nice interactive plot here. You can drag the zoom in, very similar to Bokeh. This is actually making an API call to Plotly, so it does need connectivity to run. So it's probably not the best for every environment and every application, but if you do have data and you do have a situation where you can make a call like that, this is a really easy library to work with, and it's one line gives you this nice interactive bar chart.
How would you characterize the difference is really where you go between Bokeh and Plotly? Like what mostly would you use for either one, or what would you really need to go to Plotly for that you can't do with Bokeh?
I'm not sure there are going to be examples where you can't do certain things. Bokeh is definitely going to be a far more robust solution than Plotly. If you are on a internal or public-facing website and you want a interactive plot that you've with data that you've manipulated and gone through, and run your machine learning algorithm on, and you want to use that in an environment. Bokeh is more meant for that, but Plotly, it's great for analysis for yourself. You need to share it for a presentation. It's probably going to be a better solution for that. For someone that's actually going to be in the Python environment directly. Another box and whiskers plot here. So just calling the first data frame, passing iPlot and the kind box, and it already has the different box and whiskers plots labeled. You hover over them, it has the mean, the interquartile ranges, and everything labeled for you. So it's a really nice interactive chart with that. It's hard to beat that that level of simplicity. So if you need to do a lot of quick analysis, Plotly is really handy there. And my favorite.
So they just configure a bunch of the defaults.
Yeah.
Make a reasonable chart.
That's right. So they do a lot of the work behind the scenes when you're doing the API call. So you don't have to worry about designing the you know, the colors or making those kind of choices. It does it for you. It's just a nice, handy shortcut for interactive visualization, where bokeh would be, I'd say, the opposite of that, where you control everything. And then for a nice, quick 3D surface, pass in a new data frame here, and you have a nice interactive surface where you can, you know, pass in the color scale for the pretty easily for as a parameter. So really much easier than I would say like the matplotlib solution for 3D modeling. It's not crazy, but it's a lot more involved than one line of Python. So if you want some quick analysis without too much customization, Plotly is really a great solution, and doesn't ship with Anaconda, but very easy to install. Conda install Plotly in it.
So if you were doing this, trying to do the same 3D surface, okay, would you do it? Similar,
yes.
But yet maybe not as polished.
You could get it as polished, probably more polished if you really wanted to, but it would be far more verbose than this one line here. So just to do this chart here, which is you know, has some similar features where you have hover over and you can manipulate it. There's a lot more going on here with parameters that you have to call and set up.
Oh yeah, because you're doing it yourself. Right?
Exactly. Yeah, so Plotly has made those decisions for you. It's, you know, they're for completely different use cases, I think. You know, you have bokeh for a completely customized interactive solution. You know, Plotly for a real quick and easy chart for if you need to.
You could build your own methods, right? But I'm wondering if other people sort of build. You know, you showed a bokeh website, right?
Yeah,
I'm wondering if there's their own pre-built bokeh, sort of a library, sort of, if you would, pre-built API methods.
I'm sure there's lots of people that have customized bokeh to do all sorts of things. The website itself kind of shows off a lot of great different features of it, but I'm sure there's a lot more people have tweaked with over time. The main thing I wanted to bring here is you have the option to do really customized, really specific visualization solutions out of the box in Python, or really simple, really easy one-line calls to do your basic and some more advanced interactive plots. So you have both sides of the spectrum right out of the box of Anaconda.
Do you need an account with Plotly? You said it's making an API
Nope.
call somewhere.
I do not have an account with Plotly.
I thought Plotly was a commercial product that you had to sign up with. I remember something
Yes.
on their website I did.
So they do, their website, you can, Plotly does have, a website, and you can have an account, and I'm sure if you want to store your plots and you want to do more involved hosting plots, all the work that you would do for bokeh to get it to work on a website, they'll handle for you. So it's the trade-off, how much do you want to manage, how much can you manage.
Well, since it's a free account, you're saying that your Jupyter notebook is storing it instead of you making an account on Plotly, and if you made an account on Plotly, Plotly would store it, but you're able to do it because you're using your notebook?
Right, it's actually not storing it, it is rendering it. So if you were to save this notebook and come back to it, it won't be rendered until you call it at that time. So it isn't internally storing these plots. So that's a trade-off of letting Plotly host it and doing the API call. Again, if you're in an environment and you're using a data set where you can make that kind of call over, call an API and do that, really simple solution. But it isn't it isn't going to do all every specific nuance that you might need if you're hosting your own website, for instance.
It sounds like it's the Google Charts model. Like Google Charts is the same thing. You make an API call, you get a SVG, or in this case something more complex, but some kind of graph back.
Exactly.
Okay, you may have said this before, but let's say I'm working with the data, I've got the data, I'm charting it up. go to my boss to show him the stuff, looks good, and now we get ready to present it to a client. We want the client to see the pretty pictures, don't want the client to have the data because we don't really have the data, that's what the Pandas for.
Exactly.
How can all of these allow me to do that, or is there?
I would say one of the top features of Jupyter notebooks is the ability to export into different formats. So you can export this notebook as a PDF, HTML. You can export it as pure Python, as a .py file or an IPython file. So you have different options. There are some dependencies that you need to handle for your particular environment for PDF, but HTML should be able to get that. Just export it, and here it is. Not everything is you'll have to probably tweak with, if you have images and other things that I call it external image files, and using some markdown. So you might have to do some tweaking to get it to behave with HTML or the specific export, but it is built with that in mind. So it's very easy to share the notebook as well. The Anaconda cloud, you can store this notebook in the cloud and it'll host the kernel for you. There's other options of notebook hosting.
I want to say GitHub will show notebooks.
Yeah, GitHub shows notebooks, which is nice and convenient. This notebook will be. I'll provide that for. I guess I could do a pull request or something.
Sure.
And this will be hosted on the GitHub. There's and all the cloud platforms have various different solutions for that too. So Jupyter Notebooks, which was going to be the last thing on my presentation here, is shareable, LaTeX support. The Jupyter itself also supports other kernels. Do a nice little Panda HTML script here. So there's all these different kernels that they currently have available. Some Ruby, Go. All these different languages can work with Jupyter notebooks at this time. So if you really are feeling like you got to use Ruby and you want to use Jupyter, that is definitely an option.
What did you just pull in? Jupyter kernels is what at GitHub? It's a text file?
Just go to, it's a page. This is actually what it's doing is pulling in a table, an HTML table, I believe it's stored as here.
I basically just found the table on there.
Found the table. I really can't read this, so
Double quote at the end by accident.
let me fix it here. Yeah, so this is also showing off what Pandas can do. So Pandas found that structure, pulled it in, and was able to label the columns appropriately.
That's really cool.
That's crazy.
Yeah, so it's not only does Jupyter have all these different kernels, but it right on the fly was able to do just. I'm connected through my phone, so it's like I'm not using anything really.
But that was the Pandas library, really, that
Just a parse, yeah.
Yes. There we go. So yeah, Pandas did that. It pulled in at what it actually has done that it didn't show. Is there's a list underneath that has all the different things that Pandas interpreted as possible data sources. I indexed the first one, which happened to be the chart with all the different languages. Yeah. Another fun thing with being able to minimize a cell is pretty helpful when you have some of these larger frames. So, yeah, being able to export is the, along with being great presentation, I think a really great presentation format for Python. Pulling in languages, be able to code in the in the notebook itself. It's great for replicating. If you're doing science, you can, and you really are needing to show the specific methodology that you went through. It's really great for that. With Markdown language, you can pull in all the the headers and everything, and you can really make documentation a thing that's easy to work with. So this whole presentation was in Jupyter. I was able to call APIs, able to call in external files. Really great solution for Python and data science. There's a soon to it's actually shipping with Anaconda now. It's the Jupyter Lab. It reminds me a lot of Atom, but it's a more robust IDE for Python. So that's an alpha, and it's actually shipping with Anaconda now. So that's all I have tonight. So does anyone have any questions about Jupyter or any of the other libraries? Or
Sure. I have a question about Anaconda in general. We kind of speak about this data science web divide. Are there bits of the web that get pulled into Anaconda? So if you want to run a Django site,
yes,
and you need to present some data, some science data.
Django, Flask, Pyramids, they can all be Conda import. I don't remember which ones ship with Anaconda, but they all play nice with the environment. It's very nice environment to be able to switch back and forth between the two realms. I think it's not just a great data science distribution, it's a really solid distribution of Python.
This is open source. How do they make money off this? Cloud?
I don't think they're making money off the cloud storage, but they do offer services like training. They also offer services like setting up for enterprise architecture and scoping the solution for that. I think they're a nonprofit technically. I don't. At least at one time, the Continuum Analytics I think was nonprofit, but yeah, that's more their income stream as opposed to actually the shippable Python distribution.
I'm impressed. I was thinking about teaching mathematics or something. This is actually much more useful.
Yeah. Yeah, it's. It didn't take me very long to switch away from a more vanilla form of Python to. I've been using Anaconda exclusively as my main distribution for over like a year and a half now. So pretty soon after I started using Python. So, any other questions? Okay.